Begin. Exercise 1F. Assuming you've done exercise 1E, that was, like I said, the hardest one to sort of get your head around, restricting the domain, so you can get your composite function to exist. Now, I've got an extra worksheet here to do with exercise 1E for you to practice. I've already uploaded this onto Schoology, so if you want to have a look, you can have a look at digitally as well. And the request that, I think it was this class or another class, I can't remember which one it was, but you guys asked for examples for exercise 1E. I already uploaded the video where I did 5 or 4 examples from exercise 1E. So I did question 11 and 12. Those were the main ones that students shouldn't find difficult. I did an example 5 and question 8, just to show you how I would go about doing them. So if you're still struggling on 1E, go and have a look. I've got a link there that says 1E more examples. Yeah, so hopefully you'll get your head around that. But today we're going to do to exercise 1F, inverse functions. There's really only 2 things you got to learn. And those 2 things, I'm going to keep emphasizing what you must look for and why you needed to understand what a function was, domain, range, set notations. Everything you learned in 1B, 1C is coming back here again. Okay, so let's have a look. Inverse functions. An inverse function is the process where you undo something. You undo the function so you get the inverse, right? And a classic example that we usually use would be something like this. You can have y equals to x squared, okay? And how you learned to do the inverse was you switch the x and y's, and then you find make y the subject, right? So what you would do is you would say, all right, let's make y the subject by saying switch the x and y's. This is how you find the inverse. You're saying x and y transformation becomes yx. All you're saying is, well, what happens when x equals to y, and what happens when y equals to x? Okay, at that point, how does it change the graph? That's the transformation. Yeah, we call that the inverse transformation. So here we go. If we switch the x and y's, I get this. And if I rearrange to make y the subject, that gives me the inverse equation, right? This now gives me, if I inverse the squaring, which is square rooting. So I square root both sides and I get root of x and I get y. Now remember, when you square it, you get a plus and a minus. If I ask you to sketch both of them, okay, this is what you get for a quadratic. This is what a quadratic graph looks like. Okay. If I asked you to sketch the positive root and negative root of x, this is the positive root, so root of x, and this is the negative root of x. Now I want you to notice something here. Right here, this is called a quadratic function. What type of relation is the quadratic function right now? Can I please have Michael? What type of relation do I have for the quadratic function? What is this called? A many to one. This is a many to one. What about this one over here now? On my right-hand side, the square root of x, where you have plus and a minus. What type of relation is this? Can I please have, let's go with Richie. 1 to many. So this is a 1 to many. Now notice, a many to 1 is a function. But a 1 to many is not a function. It's a relation. How do you know? You can do a vertical line test. If you do a vertical line test with both, you can see you only have, for every x, you only got 1 y. So x is faithful. Remember that. Whereas this one, if I do a vertical line test, has 2 y values. Many y's. We don't want many y's. The definition of function is you only get 1 y value. So what's the issue here? You don't call that an inverse function. Technically, that's an inverse relation. Okay? And so that's why this whole chapter here is about inverse functions. That's an inverse relation. So the question now is, well, how do you change that quadratic equation? I still want x squared. But how do I change that? There are infinitely many different ways to do this. But how do I change x squared so that I can make sure the inverse of that, which is still root of x here, becomes an inverse function?
change the domain of the original one, the range for the second one will change to here.
Fantastic. So what would you change the domain to? Give me an example.
R plus. So the domain, yeah, R plus.
Good.
The range for the other.
Yes. If you change,
Or, including 0.
including 0. You can do it this way. So what happens when you change the domain? Right now, the domain for the function, which is a many to one function, is 0, R. Okay, you can take any values. You can go left and right. It doesn't matter. But that's a problem because if you think about it, if you sketch both graphs, now it becomes an inverse relation. If you restrict the domain, so let's see how that changes the problem. See, if I restrict the domain from R plus including 0, this is what the graph looks like now. See, R plus including 0 will now look like this. It's still a function. Okay, so 0 to infinity. It's still a function, but then when I do the inverse, now here's my question. Is it going to be root of x, or is it negative root of x, or is it in between it? What would the graph look like? What should it look like? What did we learn in year 11? When you do the inverse, what also changes? The range. So the domain of your function, this is the first property, domain of your function now switches because you switch the x and y's. You're saying the x, which is the domain, is equal to the range. So right now the domain of f is equal to the domain of the range of the inverse. So that means if the range of the inverse is now from r plus to 0, including 0 all the way to infinity, which one is it likely to be for your range? Be from 0 to infinity. Is it the top line, or is it the bottom line, or is it in between? Top line. It makes sense that the graph for your inverse function will look like this. Now that's an inverse function. You see, if I do a vertical line test, all I had to do was restrict the domain. But does it have to be r plus including 0? Okay, does it have to be r plus including 0? No, it doesn't. And this is where a lot of students are stuck in this idea that you have to go to the bare minimum. No, you don't have to. You just need it to be a function. Okay, now there's a specific type of function this is. Okay, and this is where the second property comes in. So the first property was domain of f becomes the range of the inverse, and the range of f becomes the domain of the inverse. There's one more property. Notice, what am I doing here? 0 to infinity works. It gives me an inverse function. Would it work if I had this graph? Let's say from -1 to infinity. Would this one work? So that gives me 1 there too. Whoops. Would this one work? Would this give me an inverse function, or would it give me an inverse relation? How do you know?
It works on that one. It's still a function. It's still a vertical line test, but as soon as you inverse it, it would pass the vertical line test.
Absolutely. See, if I actually did this, now this, remember we said domain of f becomes range of f. This domain now is -1 to infinity. If I continue this graph from -1 to infinity, the range now is -1 to infinity, and this is what part of the graph will look like. That will be part of the bottom. That's not going to pass the vertical line test. Yes, it passes here, but it doesn't pass here. So that crosses twice. So what are we trying to ensure when we restrict the domain? This is where the second property comes in. That's all they're testing on multiple choice at the end of the exam. What are we trying to restrict it to? All right. What are we trying to do? So before 0 to infinity works, -1 to infinity doesn't work. What about 1 to infinity? Does that work? Yes, that works. What are we looking for? What are we actually doing right now? Steph.
It needs to be a one-to-one function.
Absolutely. That is all. They're testing you. Right here, ignore everything up there. The only one thing you are required, I'm just going to take this off here, is this. It needs to be, and this is the only one point in your study design that they're testing for inverse functions. They're saying, do you know that an inverse function, not inverse relation, inverse function can only exist if the function is a one-to-one. That's the only way. Otherwise, you end up with a inverse relation. Okay, and you can do a vertical line test to prove that as well. But there's only two properties in this exercise. First one, domain of F becomes the range of F inverse. Range of F becomes the domain of F inverse. We learned that last year. The only extra one thing I'm adding on today is for an inverse function to exist, you have to have a one-to-one function. Now, in case you forget this, I'm going to show you a way to remember. Let's list all the types of relations. Give me two types of relations that you know, Daja. A one to many and a many to one. Good. Many to one. Give me the other two. Can I please have, let's go with someone on the right. Rose, give me the other two relations. I got a one to many, many to one. I'm missing. One to one. And many to one. I mean, many to many, sorry. Yes. Okay. Here's the thing for you to remember or to understand. When we do the inverse function, you are saying the x equals the y, and you're switching it through the transformation, true? And when you switch it, notice the quadratic before was a many to one. That's a function. This is a function, many to one. One to one is also a function. These are the only two types that is a function. Out of those two types, let's have a look at many to one. The many to one, when you do the inverse, it switches, and now it becomes a one to many, which is what we saw before. A quadratic became, a many to one became a one to many. Out of the two functions, there are only two, there's only one that fits the criteria. If you do the inverse, one to one ends up being a one to one. That is why we say the inverse function only exists if it's a one to one function.
What if it's the one to many?
Yeah, then it's not a function. So an inverse function can only exist because we want a function. If you have a one-to-one function. But if you have a many-to-many or a one-to-many relation, yes, that is possible. But most of the time, they don't give you a relation and say make it an inverse function. But most of the time, though, what you do get is you get a many-to-one type, and you have to change it to one-to-one. And that's all they're testing in your exams for multiple choice. I promise you there's going to be one there. It's either quadratic, or the most common one that they do is a cubic. Okay, why is that? I'll show you. They do something like this. They'll say, very top here, this is A. They'll say this is B. They'll say this is C. Okay, and then they'll give you that, and they'll say R for that graph is, the domain is R, right? They'll say, if for an inverse function to exist, okay, they'll say, which one of the following domains will be correct? You restrict the domain here. Okay? So if you restrict this domain or the inverse domainal range, they'll say something like this. If you had your domain as, let's say, from A to C, inclusive, okay? They may have B, it could be B to C. They might have your domain from, let's say, maybe A to B. They might have your domain from, what else can I do? I already did that. Oh, whatever it is, okay? And then you have to choose, because I just realized the other ones work too. So, actually, I'll do that. They'll say A to C, less than, greater than C. So greater than C, X is greater than C. And then maybe E, they say A and D is correct. Actually, yeah, I've screwed up there, okay? I screwed up there, but let's see if you can pick up where I screwed up. Now, what they'll be asking you this particular question is they want an inverse function to exist. The only way for an inverse function to exist is you restrict the domain to be a one-to-one. Now, what we can see is when I restrict the domain from A to C, will an A to C give me a one-to-one? No, how do we know? What test are we doing? Horizontal, because that gives me a many x to one y. That's not what I want. This will become a many to one. A to B, I mean B to C, would this be a 1-to-1?
Yeah.
No, so B wouldn't work. And then if you look at C, now this is where I screwed up here. A to B works, because A to B is still a 1-to-1. So that's a possible answer. Then I screwed up here, I said X greater than C is true too. It works. So you have two answers here that work, and I was meant to make E technically, yeah. It was meant to be, I should have read here, normally they would say this only and AB only, and then the last one they'll say it's these two. And you see the skill that you're doing here is you're only testing one thing. You're looking for a 1-to-1. And you're doing a horizontal line test to test for a 1-to-1. Yeah? And that's what they'll be testing. I promise you there'll be something similar to that for one multiple choice. And then, so where's the other parts of the inverse come in, your short answer questions. They'll be saying, find the domain, find the range of the inverse, state or define the inverse function. Yeah? Sketch the graph, sketch the inverse. All that is in your short answer parts. That's what exercise 1F is about. So you've got algebra, sketching, set notation, domain and range, what a function is, and then figuring out how to determine what type of relation or function you have. That's why exercise 1B, 1A, 1C are important for you to understand 1F. Any question? Do you need me? Yeah, that's fine.
Okay. Now, just to summarize what I've just taught you, there's only two things you need to know, which I'll do here. In your notes, I don't want to see that. See that. After that, you can write whatever you want to understand what the slide is about. These are your two properties for inverse functions in your part of your study design that you must know how to do. After that, sketching, algebra, that's a given. You have to know how to do your algebra, you have to also know how to sketch. Okay? Alright, after this I'm going to do about 3 examples, and in those 3 examples I want you to pay attention to different things in each of them. Okay, so let's do a first one. Here's the first example. I'm going to do A and C from this one. Each one of them I want you to see the skills that are required. So let's have a look. A. First thing they ask you to do is find the inverse of each of the following functions. So you know one thing, they're functions. They're not relations, so it can't be a one-to-many and then it becomes a many-to-one function inverse. Okay? They're all functions. And we have to understand that for them to have an inverse, they'll have to be a one-to-one function. And clearly, straight lines are a one-to-one function, that works. Rectangular hyperbola is a one-to-one function. Quadratic isn't a one-to-one, but they're restricted to the domain. They said it has to be greater than 1. So they all, in the property, there has to be a one-to-one function. Okay, so they all have an inverse. So now they all have an inverse function. Let's find out the inverse. So to find the inverse, we always know we're switching the x and y's. It's the reflection in your y equals x line. So now we have our equation. Instead of y equals 2x plus 3, I now have x equals 2 times y plus 3. Rearrange them, minus 3 on both sides. Y is equal to x minus 3 on 2.
Is that my inverse function? Yes. But don't leave the answer like this. You do this in your exam, you do this in your second lose a mark. Okay? And I told you at the very start, when I taught you function notation, I said, anytime they ever say, find your inverse function, to find an inverse function, especially if it's 2 marks as well, do not do this. Where did the y come from? It looks right. Yeah, I know what you're doing. Examiners aren't going to assume you know what you're doing. They're all going to assume you're dumb. They assume that you don't know what you're doing. You've got to show them what you know. Yeah? So, you write y, you write that, I don't know what you just did. I know you just switched it, but I have no idea what you're doing. What are you telling me right now? You haven't told me anything at all. This doesn't make sense. I gave you an f of x, and you give me a y. You're like, here we go. You didn't even say that this is the inverse function. You didn't even tell me domain or range or anything. You were just saying, this is y equals, I'm like, great. It's nice to know that y equals to x minus 3 on 2. But it doesn't tell me anything. How are you meant to write your answer at the very least? Even if you don't write your domain at this point,
you don't write your answer like that. You're meant to write inverse of f of x. That makes more sense. That's the notation for the inverse of the function f is equal to x minus 3 on 2. But I'm trying to drill in. I want you to use function notation anytime they ever say state a function, define this, whatever it is, write it as function notation. Now, in order to write your function notation, you need domain and range, which is why you have 2 answers. I mean, 2 marks. That's why they always give you 2 marks for these type of questions. And that's a big hint that you're meant to write as function notation. Okay, so here's the next part. You got domain of f, which they already tell you. They said it was -2 to 1, so -2 to 1. From the second property, we understood that the domain of f becomes the range of f inverse. Okay, so this means now this is the range of your f inverse. And so now what is the range of f? Because we know that's going to be the domain of the f inverse, which is what you need to write a function notation. Right? How do you do this part? This is what I was saying back earlier last week. I said to do methods well, the better you can sketch the graphs, the better you can see it, the less mistakes you make. Okay, so for a 2-mark question, if that was questioning, it was a 2-mark that said to find the inverse function. You're losing a mark if you don't write the domain. So how do you do this? Sketch it. Sketch the graph, or if you can picture it already in your head, all you have to do is put in the endpoints. Okay, for me, I always sketch it to make sure you guys can see what I'm doing. Okay, eventually you don't have to do that. I'm just doing it for you to see. Yeah? I know this is a positive gradient, a linear graph. Y-intercept at 3, so y-intercept at 3. I know it's a positive graph, so I know it has to look something like this. But there's a restriction. They told me the domain is from -2 to 1. So I know, okay, well, it's -2 to 1 is -2, and it goes to 1. I need to know, this will tell me my maximum y range and my minimum y range. Okay? So now all you have to do, see, logically, if you look at that graph there, you're like positive gradient, y-intercept, you've got an idea what you have to do. Sub in -2 to find out the y value here, and sub in 1 to find out the y value up here. Okay, so when x equals 1, clearly 2 times 1 is 2, plus 3 is 5. So I already know x is 1, y is 5. When x is -2, -2 times 2 is 4, -4, plus 3 is -1. Now you've got the graph, it's easy to answer the question. You know the domain, the range has to be -1 to 5. So now I know it's -1 inclusive to 5. Okay? Writing your proper answer. If it's a 2-mark question, they ask you to find something, this is how you're meant to write it. F -1, colon, your domain, which we know is -1 to 5, maps onto R, that's your codomain. F inverse is equal to x minus 3 on 2. Can you see how that's warranting 2 marks and how that looks more of a year 12 technique than it is for a year 11? Year 11, year 12. See the difference? It's very pedantic on that. You've got to read the question. That's how I want you to write them. That's how you get your 2 marks. You have your domain and you have your function. That's what I want to see. Anytime they say state an equation or something, that's how I want to see it. Okay? Now this is a typical layout for an inverse assessment. What they're testing here, algebra. Can you do inverse operations, year 7 to 9? Yeah? You come over here, can you use set notations and interval notations, domain and range? What we're doing this year and last year. So language. Can you sketch? With the restricted domain or implied domain. Now the only part you're missing, where they might ask you part of that question, they'll say, sketch the inverse. Sketch the inverse and the function in itself in one. Okay? That's a whole very nice one question. Find the inverse function, domain and range, and sketch the graph. Very nice one question where it assesses most of chapter 1. Okay? That's why it's expected that at the end of the year you're going to get something like that. Obviously not that easy, not a straight line equation. It'll probably be an exponential, log, maybe a grade, truncus. You have to restrict the domain. Okay, but 2 properties, all the skills you need to do the exercise. Yep. Yes, Alessia? They'll give you a mark for the equation. They'll give you a mark if you just get the inverse. If they give it 2 marks for that question, you get 1 mark. For stating the correct inverse, you won't get the domain there. Okay, so if they say define, the word define, this is defining. You can give 2 marks. If they give you 1 mark, you might be able to pull through. It's just an equation that domain.
But if they ask you to sketch it,
Yeah.
do you have to sketch the original and the inverse? So will you lose marks if you don't sketch the
Oh, no, they'll tell you. They'll tell you. They'll say sketch F and F inverse on the same axis. And they'll give you an axis for it as well.
What if it was a two-mark question and you wrote out the rule of the graph on the side, like x, where x is an element of something?
That's fine too. Yeah, because you're still qualifying 2 parts that you had to go through some sort of process to get that answer. So even if you did write it as a function notation, you still answered the 2 parts of it. Did you get the domain correct? Or did you get the inverse function? Okay, so if you write those 2, that's perfectly fine too. It's just that just looks nice. That's all in one go. Yeah. Any other questions? Cool. All right. So that's the gist of what you're doing for this exercise: sketching, algebra, getting your notations, set notations correct, and defining it. Yeah. Now every other question, now they're just going to give you a bit of tricks. You know, they might have, for example, this graph here. There's a reflection in your y-axis, so you know that rectangle is traveling the other way. This one's a bit tricky. I want to do C. I want you to have a look at C with me. Let's have a look at C. Okay, let's look at C. If we were to sketch C, this is what C looks like. Oh, what happened to my pen? Oh no. Something happened to my pen. Maybe. Or maybe it just ran out of battery. No! Well, maybe I can just use the traditional marker. What is it?
I don't know this side.
There we go.
No, that one.
Yeah! It's back. I got ink. All right. Here we go. Let's sketch. Shh, shh. Listening. Shh. Oi. Thank you. We're going to sketch x squared minus 2 where the domain is greater than or equal to 1. So here we go. This is what x squared minus 2 would have looked like, but because, and it has a root 2 here as well, positive and negative root 2. But because it's greater than 1, 1's about here, so I know the graph will look something like that. Okay? So that's roughly my graph. Now I've got a graph, that means I know the domain as well. You know, the range you can actually find out by substituting 1 in, and you'll know what the range is from here onwards. Okay? Let's start off with finding the inverse, and this is where it's tricky. Not yet, actually, but what you have to pay attention to. Yeah? Everything I taught is in the last slide is all you need to know for exercise 1F, but now you just got to be pedantic with the little details. Yeah? If we were to find the inverse, this is what you would have done. You would have said x to y, and you would have had y to x, that's the transformation, and you would have had x is equal to y squared minus 2, inverse both sides, so that becomes x plus 2 equals to y squared, and you square root both sides. Now this is where it gets tricky. You get 2 equations. That's not how you write it as well. You're meant to write f inverse of x equals 2. Now, is that correct? Why? I've used f of negative 1x. What's wrong with my equation? X is not bigger than 1. This one?
No, yeah.
That one, the domain. How's that affected? It goes back to my first property. I gave you 2 properties to remember. I told you to write it down. How does x greater than or equal to 1 affect my graph? So let's see. You're still losing a mark in my equation. Why am I losing it? You're right, that's okay. If you find out the domain range, it's fine. Something's wrong here. What's wrong, Trent? Yeah. Yeah, there are 2 possibilities here. That's not a function, that's technically a relation right now. If you actually sketch the graph, it's a relation. So to make it a function, you have to know which one it is. Is it the positive or negative? And that's what you're saying. When x, the domain, remember domain of f is equal to the range of the inverse, which in this case is x greater than or equal to 1. Now if you were to sketch this graph, the inverse, that is just moving to the left. It's a square root function to the left, and it's positive and negative. So to the left by 2. Now that's your root x plus 2, and this is negative root x plus 2. Now that you know that the range of f has to be 1 greater than or equal to 1, which one is the answer? The top one. So the only top one will have a range. That's the only one that would have 1 to infinity. That's why this will be wrong. And that's what a lot of students do in your SACs and your exams. Most students, they haven't done anything wrong with their algebra. It's now your domain and range with your properties. Goes back to the number 1. So I told you there's 2 properties in inverse that you have to be careful of. Domain of f becomes the range of the inverse. That plays a lot to do with your graph, and hence your equation. Okay, so your equation should not be a plus and a minus. It should actually be root x plus 2. We know it's positive. Sometimes they'll do it where it's negative. See, that's why you have to pay attention to it. Okay? So now that you know it's a positive, and we know this can't work, and now you just need to know it's from 1 onwards. So it was from 1, so it might just be about here onwards. Okay, so that's the graph of the inverse. Now you can answer the questions. You were meant to find the domain and range. You already found the range. Okay? You already found the range. You just need the domain. So to find the domain, you need to find the range here. The only way to find the range is when x equals 1. So when x equals 1, in my quadratic equation, I'd have 1 minus 2, which is negative 1. So I know down here, my range is negative 1 to infinity. That means my domain of my inverse is now negative 1 to infinity. Okay, so that means this is negative 1. There you go. Okay, so if you were to write this as a function notation, the proper way of answering the question for a 2-mark question, f inverse, colon, you know that it is from negative 1 to infinity, maps onto R, f inverse of x is equal to root of x plus 2. See, that's your proper answer. So you get 2 marks there, getting the correct equation for the inverse, and getting the domain in there correctly.
Your range inverse, would it be wrong to say x is greater than 1? They don't equal, like x, your range is 1. Further, you don't have equal range of inverse equals greater than 1. No, like, it's wrong. Was it?
Oh, I see what you mean.
That'd be a thing, or
Yes, actually, maybe you should write it the other way around. So you should do domain of f is equal to x greater than equal to 1. And you write on the side equals range of f inverse. But I know what you mean by using the x variable here. Using the x variable. If you were to define it correctly, if you wrote range of f inverse, y element of 1 and greater, that's fine too. Okay, this is just how we normally say it. Well, we're referring to the domain of f. But the way I wrote it, it looks as if range of f is equal to that. If I wrote domain of f equals to x greater than or equal to 1, and then I wrote range of f inverse, that's fine. All right, one more thing, just one more to finish off your understanding. Here's a problem. So all of those are simple. You got your quadratic. Pay attention to the domain, what a function is. Make sure it's a one-to-one. And here's this example. How do we do this one? It comes up generally in your exams or SACs. These are common questions to work with for inverse, because a lot of students normally don't do the last few questions of your exercises, and that's where it comes in. Yeah. So let's have a look at the first one. I'll do the first one, and I'll get you to think about it. They're saying B, you don't know what the domain is, but remember the domain has to make this function a one-to-one function, not a many-to-one. So that's the first thing you're looking for, yeah? Second thing is, you got to find the inverse. Now, if I just called this y equals to x squared plus 4x, if we do the inverse, tell me, what do you notice as a problem immediately? What's the issue? Why is this a problem? What are we trying to do when we're trying to find the inverse? What are we trying to do? Make y a subject.
The problem here is you've got two y's. You see, that a lot of students, what they do, this is what they do. They're like, yes, okay. And there's two varieties here. Students will say minus 4y because they're used to just subtracting. They get up to this step and they square root both sides. And they look at it and go, that looks a bit weird. Then they try another method. They're like, maybe I'll do this. Take out y as a common factor, and you get plus that, and they divide it. And they're like, I'm not actually sure now. And they get stuck. And they sit there for a while. Move on if you forget how to do it. Just move on, okay? Because there's no point. You're not going to get any marks after that. Your first mark is figuring out how to do this. You get the first approach correct, you get 1 mark for that. So the question is, what toolbox do you have since you've learned from 7 all the way to 11? Whatever you learned so far to change 2 y variables to make 1. It's only one technique we learned. Somewhere towards end of year 9, maybe all of year 10. Yes, it is something to use squares, but it's not called magic squares. Perfect squares or completing the square. Yes. Whatever that technique you're thinking of, remember completing the square allows you to factorize 2 variables to make it 1 turning point form, which has only 1 variable. So if I were to complete the square now, that's the only one technique you have to do. So if you ever get that kind of problem, that's the one thing you have to remember. That's how you change them. So this is wrong. That's not how you do that. And neither this is how you do it. It gets you nowhere. Your job is to make 1 y variable. So how do you do it? Completing the square, we know it's y squared plus 4y. Now you add on a constant to make a perfect square. Half the b term, square it. Remember that technique? Half the b term is 2, 2 squared is 4. So that means for it to be a perfect square, I need to add on a 4. But you can't just put in a 4 out of nowhere, so that's why we subtract the 4, because that technically hasn't added on anything. I put 4 in and I take away 4. But the nice thing about this is a perfect square. Okay, that's your a squared plus 2ab plus b squared. That's what it is, yeah? So this now is y plus, and it's technically 4 divided by 2, which gives you 2 squared. See, if you try to expand that now, it makes a lot of sense. Square the first one gives you y squared. Square the last one, b squared, is 4. 2ab, a times b is 2y, times 2 is 4y. That's your a squared plus 2ab plus b squared. That's the square. And you've got a minus 4 on the outside there. So minus 4 equals x. Now you can solve it. Now you got 1 y variable. It's possible. Add 4 on both sides. You now get x plus 4 is equal to y plus 2 squared. Square root both sides. Be careful here. You got y plus 2, and then finally y is equal to negative 2 plus minus root x plus 4. This is not your answer yet. What do you have to pay attention to now? The domain. So what I said before. So these are things you have to pay attention to. So the domain is what's important. And they told you the domain is something to infinity. So you know that the quadratic graph is from the right-hand side. It's b onwards on the right-hand side. So when you do the inverse, your range is going on the top. So it has to be positive, not negative. Okay, that's how I know. Because I'm looking at this domain here, which is the range of the inverse. And the range of the inverse goes to infinity, so it has to be going up, not going down. Okay? And that's how you start those questions. But just in case you get to that point and you're sort of confused, that is the one technique you're using here, completing the square. Okay? And the rest is up to you. I'll do some examples in the video just so you can see how I do exercise 1F. I'll pick out the tricky ones to do. But that's all the techniques. Exercise 1F, 2 properties, algebra, sketch, and those 2 properties. That's it. Okay? Just trying to end up being like y squared plus 4y plus 5. Stops. You still complete the square. Alright, thank you. I think you got about, what, 15 minutes, or no, 2 minutes left. So you guys can pack up. I'm just going to end the video here, but I'll make more videos for some examples for exercise 1F in case you're struggling with some of the questions. Okay?